For this problem, you may want to have that previous page handy, this one, so that you can refer back to all of those little bits and pieces. So it says, what is the standard form of the ellipse that has the vertices -2, -8, and -2, 2, and foci -2, -7, and -2, 1? Well, the first thing that we have to notice is that the x coordinates of the vertices and of the foci are all the same. So let me write out a little note here. Since the x coordinates of the vertices and foci are the same, the major axis is vertical. Now, sometimes it may even help you if you sketch out a picture of this. So we have -2, -8. That's a vertex. We have -2, 2. That's a vertex. We have -2, -7. And we have -2, 1. Those are the foci. So we know that it's going this way, right? So we can see that we have a vertical major axis in this case. So let's look for our center. Remember, the center is in the middle of your major axis. It's also in the middle of your minor axis. So we just use the midpoint formula. Our center is HK. The midpoint formula is the sum of the x's over 2. So the sum of the x's would be -2 plus -2 over 2. And the sum of the y's over 2. So -8 plus 2 over 2. So the center is going to be -4 over 2, -6 over 2. Our center is -2, -3. Didn't really need to put a box around that because they want the equation. So this is not our answer, but having that box will draw my attention to it, that's for sure. So we have our center. Let's remember what our formula looks like. We have x minus h squared plus y minus k squared, both of those over something, equals 1. Whenever we have a vertical major axis, our A goes under the Y. So now we need to find out what A is. Since we know the vertices of our major axis, we can find A. Okay, so how do we do that? Remember that the length of A is 2 times this distance from the center to the vertex, or it's half of this distance from vertex to vertex, right? So if we look at that, we know that from this vertex to this vertex is 2 times A, right? Because one of those is A. So 2A is equal to, well, what is the distance from here to here? We could say that is 2 minus -8. So 2A is equal to 10, which means A is equal to 5. You just need to know the distance from the vertex to the center, and that's going to give you your A value. Okay, so we have A. Let's put a box around that so we know where it is. Now, how can we find C? We're given our foci, so we can find C. Remember, in this particular problem, your foci are going to be somewhere in here, right? So you take your center and add C or subtract C. So what's changing, X or Y? In this case, x is staying the same. So we have our h, which stays the same, and then we have our center plus c, and we have our center minus c. So how does this work? We have our center, hk, so we have -2, and then k plus c, that's -3 plus c. Well, this has to be one of these coordinates, right? 2, 1, -2, 1 would be here, and -2, -7 would be here. So -2, 1 is where we add c. So -3 plus c has to be equal to 1 because our point was -2, 1. This has to be 1. So if we add 3 to both sides, we find out that c is 4. If you use this form, you would use this point, and you would still get c equals 4. Okay, so now that we know c, that doesn't go in our formula, but now that we know c, we can calculate b. Remember, we have our a, we know our h and our k, we just need our b. So let's calculate b. Remember, c squared is equal to a squared minus b squared. So c squared, that's 4 squared, a is 5, and we're looking for b. So we have 16 equals 25 minus b squared. 16 minus 25 is going to be -9. So b squared is equal to 9, which means b is equal to plus or minus 3. So now we know b. Can we put everything into our formula at this point? It's x minus h, so x minus our center, right there, -2, x minus h squared over b squared, b was 3, right? Plus y minus k, k is -3, over a squared, a is 5, and that's equal to 1. So we have x plus 2 squared over 9 plus y plus 3 squared over 25 is equal to 1.